In the combinatorial array, Rishon fundamentals are considered to be elements of the combinatorial groups. And we can see we have the elements A, B, C, D, E, F, designating Rishon fundamentals. A given order of group may constitute a spin network, so each of these groups may constitute a spin network. Each subset of groups in the array identified by a common beginning letter constitutes the volume at a point in the spin network. So we can see here we have this subset of groups all beginning with the letter F. And so that subset will constitute, as we'll see, the volume at a point F. The order R equals 3 groups identified by a given letter are produced by the lower R equals 2 group identified by the same letter. And so here we have this group identified by the letter F. Well, then is produced by this group identified by the letter F. And we can see a union between FB and FA will give me FBA. A union between FC and FA will give me FCA. And a union between FD and FA will give me FDA, and so on. Note that each subset of groups identified by a common first letter is partitioned into smaller groups with numbers of elements starting at j equals 1 and increasing in counting order to n minus 1. So n being the number of elements in the producing group, 5. We have a partition here indicated by the parentheses with one group. Then we have a partition with 2 groups, 3 groups, and 4 groups, 4 being equal to 5 minus 1, or n minus 1. So j equals 1 to j equals 4. The number of unions and elements produced for each n minus 1 partition, n minus 1 partitions of the order R equal 3 groups will equal j times j plus 1 divided by 2 minus j. So for example, for this group, for this partition of groups, j equals 4. So 4 times j plus 4, which is 4 times 5, is 20, divided by 2 is 10, and take away 4 is 6. So this group produces these partitions of 1, 2, and 3, which adds up to 6. And in this case, j equals 3, so 3 times 4 is 12, divided by 2 is 6. Take away 3 is 3. And so it will produce this partition divided into groups of 1 and 2. And then we will have this partition which has 2 equal to 2 times 3, which is 6 divided by 2 is 3. Take away 2 is 1, producing this next one. So we see that the number of unions or elements produced for each R minus 1 partitions of the order R equal 3 groups will equal j times j plus 1 divided by 2 minus 1. So for the spin network equivalent to a set of order R equal 3 groups, a point or vertex is designated by the letter identifying a subset of partition groups. So F is identified with this these partitions. So these 1, 2, 3, 4 partitions will make up the volume here at F. In the spin network graph, each partition of the subset of groups is indicated by a line segment terminating at the point or vertex. So we can see there are line segments coming to F. And this will indicate the volume that's going to be. And these are each associated with these partitions. For instance, this line segment has associated with 1. So it is the partition having 1 group, and so forth. 2, 2, 3, 3, and 4, 4. The line segments indicate the number of groups in that partition associated with the volume at F. The volume, as noted, has a factor equal the square root of J times J plus 1, which, as we have seen previously, is a factor associated with the count of relations between the Richon's fundamentals. So this means that this indicates that the geometry of space-time volumes are comprised by the relations. The geometry of space-time volumes are comprised by the relations of the Richon fundamentals. And so we can see that each of these vertexes is associated with one of the letters that begin each subset. And so we have F, we have E, we have D, we have C, and then A and B are empty volumes where line segments are actually not terminating there but beginning there, bringing these in relationship, but are terminating at the volume here, like in this case F, or in the case of E, or in the C, or in the case of D.